Thank you so much for joining this channel. We are in day 18 now. So day 18 is nothing but you can say the summarized version of day 1 to day 17. Whatever concept we have learned from day 1 to day 17, say for example, a single agent, multiple agent, supervisor pattern, observability, MCP, tool connections, so many things, right? So all will have tried to use in a single enterprise application. Why I say enterprise? Because if you use scalability, runtime, router, all the concept, it actually reaches to the enterprise level. So take recap of the day 1 to 17 engineering capabilities already have built up the major things like MCP cloud migration because cloud migration started from the day 15.5 performance optimization like prompt caching and other things, observability, telemetry, tool plugging, multi-agent. So all will be clubbed together now. So why is the AI agent architecture? Because you can make it scalable, intelligent planning using supervisor pattern, tool ecosystem we are using MCP, observability and telemetry and reliability also. Because if we are not sending only the prompt, we are giving the taking the tool support, and we are helping the models, Olama or the OpenAI, to take decision, not using hallucination rather than based on the real time input, like using the MCP or the tools. If it is inside, then tools. If it is external tools, then it is MCP. So high level request, we are sending a request in our agent API. We will develop using API also, but right now it is a console application, so you can replace the API with the console in the mind, because we are planning to upgrade the previous days with the APIs that will be in a different playlist. So now it is console. Console again talk to the Azure runtime. Sorry, agent runtime. Agent runtime will talk to the router. The time is out. So router and the supervisor and all supervisor and router both together will work on these individual agents, and agents will individually call the MCP tool, and then finally the response of the MCP along with the system prompt will be sent to the OpenAI model or the Ola model from the worker agents, and all responses will be aggregated and sent back to the user. So with the business, it will be like taking the decision. Once the runtime will be called, runtime will first contact the router. Router will filter the request, and based on the filtration, whatever the final filter output will come, or the request will be taken, and then based on that, the worker agent will be ready using the supervisor pattern. We will show in the code. Worker is nothing but the individual agents, yeah, that node agents. MCP tools, it is an external call, but since we haven't have this setup of GTPIs and everything, we're using a demo, a pseudocode to understand how MCP works with each and individual agents. Observability we already introduced in the day 14, so now we are just using over here. Parallel execution, to reduce the latency, and also that if it is independent agent, you can agent execute parallelly, so all will be taken care by the agent runtime. So now finally use case DevOps, right? You need to DevOps automation, you have a Jenkins, you have a code repo, security, so many things you need to call Kubernetes. So you can use this concept to make a full-fledged DevOps automation. So right now what we are introducing in this day 18, it is a that a package of day 1 to day 17 having runtime, router, supervisor, parallel agents, agent context. You just remember these keywords, which will help you when I discuss the deep dive in the PDF followed by the demo. So next phase we will go for the services different thing that is a different thing to the final demo. So you can see that our foundation is similar, same .NET semantic context, OpenAI, Ulama, and model context protocol that we are using right now, and it is nothing but integrates AI agent using day 1 to day 17, all the concepts. So we have done so many things. You can visit this in the previous days, and you will get a more idea. Either you can visit this day 18 and then you go back, otherwise you can come from the day 1 to day 18. It's your choice. So when I say single agent, we have done till day 9. There is no orchestration, no tooling, nothing. It's only that how the agent works. But when I say enterprise, it should have all the facilities clubbed together. Then only you can say, right, it is complete enterprise AI agent. So this is the flow. User will send the request. Now API gateway, just think about it as a console. Console will talk to the runtime. Runtime will talk to the router. Router will filter the request, the purpose, and then this filter item will be sent to the supervisor. Supervisor will plan which one to call, which one not to call. So this planner will take up. Suppose there are three worker agents, and suppose the request came for only these two, code review and the security. So these two will be called by the supervisor, and then parallelly it will be executed. And when it will be executed, each individual agent will talk to the MCP layer. Suppose for code review, it will take the code metrics. For security, it will go to security scan. So once these details will come from the MCP layer along with the system prompt, the individual agent will talk to the OpenAI to get the final response. So this is the reason for less hallucination. The result will be more reliable. So you remember this architecture. And in the upgrade section, we will replace the console with the API calls. So what is agent runtime? As I say, agent runtime actually managing everything right from a router and the supervisor, right? So it is like a facade layer managing execution, routing, all these things comes under. So it is a gateway from the API or the console. So router is it is filtering based on the user, so that unnecessary agent should not be called. So we will do the planning based on this the information who is true or false. It will plan which worker agent to call. Worker agent is individual agent. There already because everyone using a single responsibility. MCP layer, this is layer nothing but it will assist the each and individual agent to take the decision, right? Because this individual agent will talk to the models And before talking to the models, it will collect the information from the MCP, and then through system prompt, it will talk to the model to get the less has hallucinated and reliable response. So this is the flow console. Now that time we have mentioned API for the long-term perspective, but it is execution model, console, runtime, router, supervisor, agent will talk to parallel, agent will talk to the MCP, and finally agent will talk to the OpenAI to get the result. So user send the request. It is in English term right now. Just keep it in your mind. Agent runtime will start the execution. Router will filter the request. Supervisor create the execution plan. Agent. So whatever I have discussed, the same thing is mentioned over there. If you remember these things, the rest of the things are easy. Architecture, as I said, this is the code base. These all files are actually to help in taking the decision using AI. So AI actually introduced these files. Otherwise, before AI, only we are working with this sample. Sample means think about there is a project with so many files. Now we're taking only one. So we'll discuss runtime. Runtime we'll discuss routing and everything, how each and individual is actually code has been written and how this flow actually. So flow already discussed. We'll show in the execution flow. We'll show in the code also. This is the demo. If you based on this user request, the router will work. If you want code complexity, then only one agent. If you want vulnerability, then two agent. If it is all, then all agent, right? So this is the output kind. You can show the logging. You can see that how this individual agent is performing. The output will come like this. Let's go to the demo. That whatever we discuss in the PDF, same thing. Agents, MCP models, planner, and runtime. All these things I mentioned. So let me run this. So now you can use OpenAI also. If you use OpenAI, the model will behave more accurately because it is all our OpenAI model. But we have taken Ola because I don't have the setup right now. So you can take the Olama. The response may come, yeah, means false or true, whatever, but at least you understand what exactly we are doing. So cloud and the local only, this is the difference. The rest of the code is as it is. So let's run it and debug it and understand how the flow it is. So now first it will set up the router, then it will call the supervisor agent setup. Finally, runtime will take the router and the supervisor. Then the actual code file will be taken. So code file is nothing but the code file is written in such a way that it will contain the security also, some code review also, and you can write test cases also. This is the small file. And finally it will call this. So you are sending this is the request, perform complete code analysis. Ideally it should call only the code analysis, should not call other security or the that test cases. But I think that Olama may send that too. So let's bear it. But if you use this OpenAI, then you will get more accurate. But now it is showing all the agent to be called, no issue. Then you actually understand how agents are working. Go inside. So we are now agent runtime, logging activity, as I said, observability. So now this is the request we are sending from the user, and this is the code file we are taking. So first, what is the router will be called, right? So router will check whether this contain our request or not. Since it contains the requests, so it is not so request not ignored. Now we'll call the supervisor. The supervisor will send this information request and will ask the Olama, okay, you just give us the final output, okay, which agent to be taken up. So now let's see. Now it actually came. So now it is see that true. I hope if you use the OpenAI, maybe OpenAI will send run code reviews true, security and run test case false. I hope so. But in Olama, it is coming true. That's not an issue. Now it is true means at least you can see how the each individual agent is working. So now agents has been decided which agent to call. Now the each agent has this execute async that will be called, but it will be in a parallel mode. Now each and individual will be called. Now once it is going to the agent, each agent actually having a MCP registration, right? Because it will have to call. So that we are doing right now. See, the registration has been done. Finally, this will be called. See, now this has been called. Now it will check. There are some agents, right? There are MCP tools, but it will pick up the tool which is required. It has all the registration tool registry. Tool registry says to tool. right, required. But now if for this agent only want to be executed, now it will go inside and it will find out the information, tool information. And then once the tool information came, so I haven't done that, just remember the tool information came. This tool information with the system prompt should be sent to the Azure OpenAI or the Olama to get the final response. As of now we are sending back the same response from the MCP tool. If you want to see that how this MCP information along with the prompt to be sent, please visit the day 12. Day 12 you will get all the details. Then you have to write one more prompt. In the prompt you have to send that the metrics details, and then based on that the Azure OpenAI models or the Olama will not do any hallucination and give the final result. So this has not been written because it has already been discussed in the day 12. Please visit that, and then you the rest of the things are same. So this result will be irrelevant result, but right now we are not calling, we just make a note, we are sending the MCP details. But remember one thing, don't send back the MCP details to the user, because MCP is to help the agent, not the user, right? The agent will take the MCP help and take the decision and give the response. That will be the output for the user. So don't confuse with the MCP response and the Olama or the OpenAI model response. So now it came. Now we will go to the another agent, since we all are parallelly, right? So now we came to the tool registry because it is calling for the security agent. So security agent also do the same thing. We have to call a Olama, but right now we are not making any call. That you can get in the day 12, 12b, 12c. So now the test case agent. So in the test case agent, there is no you are not calling anything. Means any MCP tool not required. So it will simply, you can write some prompt here also to execute test case generation. So test case, if you want to write a test case using this agent, then you can visit the day, I think day 13, you need test case agent. So you have to make a call to LLM to generate test cases, and that will be given as a response. So now we have hard coded. Okay. So let's see finally what is happening. So now we have executed all, and in the parallel executor, what we are doing. So once all are finished, tasks final, then only it will be come back, and then we will print the result as well as whatever tool has been used. See this type of information. Tool use this code matrix and security scan. Now runtime request received. Review the code, runtime security scan, generate test cases. Test cases generation means you can visit the unit test case day and code review completed, lines number, whatever you want, and the test case suggestion. So hope you understand that how all the pattern, design pattern, and the other concept that we discussed earlier being used. Like okay, so please visit the earlier days if you want more detail that I mentioned. Tool information, how to use day 12, 12b, 12c, and the unit test case is 13 or for 13, 14 for the observability. Okay, thank you so much. We will visit again for the next video. Thank you.